Hello, so in this lesson we're going to look at roots in our polynomial graphs a little bit. So this is kind of going to be an investigation where we're going to look at a couple different graphs for a couple different degrees, different types of polynomials. We're going to kind of notice some things about them, and then we are going to kind of connect it all together in a summary and kind of see what did we notice happened on our pictures. So we are going to kind of use a graphing calculator. We're going to use Desmos to help us kind of look at some of these. But we're going to get a couple different examples. So to start, we got f of x equals x minus 5. Now, we can use a graphing calculator here, but guys, this is a linear function. All right, remember back in the day, slope-intercept form? Y equals mx plus b. Guys, this is in that form. Look, there's really a 1 here. 1x minus, remember plus and minus. Minus is just plus negative. And then b is 5. Okay, so guys, you could technically graph this without a graphing calculator. If you remember that b is your y-intercept, negative 5. There's your b. And then if you have a slope of positive 1, then that means I go up 1, right 1, up 1, right 1. Or remember, you can go down 1, left 1, down 1, left 1. Okay, and you get your linear function, your line. Okay, so I do have this thrown into the graph in Desmos. Okay, we'll briefly look at it, but say could probably do that one without a graphing calculator. So it's a linear function, so my degree is my highest exponent, which, remember, what number do I have to write right here? Or that I don't really have to write, but is right there is a 1. So this is a degree of 1, which is why it looks linear. And then reminder, guys, your degree and your number of roots/solutions should always match up. Now, remember, this is not necessarily talking about real roots and solutions, which we kind of get to look at in this lesson a little bit, okay? But the degree and the number of roots and solutions, both real and imaginary, should match up. So that's going to be 1 and 1. And now let's find out what that is. So the x-intercept. Now I already have my graph. I see that it's going to be positive 5. So we're going to put x equals 5. And then the last thing we're going to talk about is behavior. So looking at the behavior here, we're going to see, does it cross or touch the x-axis? We're going to see that it crosses through the x-axis, meaning that it starts down here and then shoots through it and then goes up top. Okay, so we're going to look at examples of other ones here in a second, but linear, pretty straightforward. 1 degree, 1 root/solution, x equals 5. It's real. Crosses. Okay. So moving on, we're going to look at this next one here, a quadratic. Now look, all these to start are going to be in factored form. So guys, there's kind of 2 other ways that you can kind of do this. We're going to write it out in simplified form here in a second. And then for this one, I'll briefly talk about how you could put this in standard form. It's just going to be a lot of multiplying, but let's start off with the simplified form. X minus 4, x minus 4. Look, since they are the same, I can actually combine this into a single x minus 4 squared. And x minus 4 squared. So I'm going to write it like that. Now, guys, could I multiply this out? Like, yeah, you could FOIL this out. Look, x times x is x squared. All right, x to the negative, or times negative 4 is negative 4x, negative 4x, and then plus 16 when you finish out the FOIL. Okay, now, the minus 4x can combine into x squared minus 8x plus 16. Like, look, that would be the standard form. So, look, I kind of just showed you 3 different forms you can write it in. You have a factored form up here. You were able to simplify this a little bit into x minus 4 squared. And then you have the x squared minus 16x plus 16. There's the standard form, okay? Now, guys, here's the benefit of having it in factored form or the simplified form here is you can kind of find the x-intercepts kind of easily. So real quick, before we do that, the degree here. Now, guys, obviously in standard form, like we've just been looking at the highest exponent. Yeah, degree is 2. So look where we can get that from the simplified and the factored form is if you... I'm going to clean this up a little bit. If you take kind of the multiplicities, I lost my parentheses here. If you take these here, this is a 1, this is a 1. If you add those together, then guess what you get? You get your 2, which is going to be your degree and your number of roots/solutions. So we'll look at this again in the next one, but in factored form, you're pretty much just adding up the multiplicities of each of your factors there. Okay, now let's look at the graph. So I am going to go to Desmos. Right now I have the line in there, right? That's the last line we looked at. Y-intercept negative 5, x-intercept of positive 5. All right, so I'm going to put our second example in, the x minus 4 squared. And now take a look. This hits the x-axis in one spot. all right, 4, 0. So as I go back to this, okay, I have that x-intercept 4, 0. Now, let's take a look at what did it do there, all right? This graph jumped down, touched that 4, 0, and then shot back up. Okay, now I'm just going to draw kind of a rough sketch of this, okay? We're not going to be too accurate because I'm mainly focused on the x-intercepts right now. But this is what happened for this graph right here. It came down and grazed that 4, 0, and then shot back up. Okay, so I see that my x-intercepts are 4 and 4 from my graph. All right, maybe the next one I'll talk about how we can get that from factored form. Okay, but what was the behavior is, look, it crosses or touches the x-axis. These touched the x-axis and then shot back up. It didn't cross through like this, okay? It shot back up. Okay, so looking at this cubic here, all right, you have an x minus 1. There's not much going on here, but then look, x plus 3 and x plus 3. I can combine those to x plus 3 squared. Now, guys, if you multiply this all out into standard form, you would get x cubed as your highest exponent. You might have to do that in level 3, but we're not really going to talk about it right now. Instead, look at your degree. Now, yeah, could I add up all these 1 degrees here and get 3? Sure. Or look, if I add that 1 degree plus 2, you get a degree of 3, a cubic. Now the number of root solutions should be the same. Now real quick, let's talk about, before I even look at the graph, how you can get your x-intercepts, your x-equals is. Guys, if you remember solving quadratics, when you had like a factored out form, like this x minus 1, x plus 3, x plus 3, what we did to solve these algebraically back in Unit 8 was you set it equal to 0, and then you set each factor equal to 0. X minus 1 equals 0, x plus 3 is equal to 0, x plus 3 is equal to 0. Guys, look, you could do the same thing here, which is why factored form's kind of nice. If I add 1, then look, x is going to be 1. Minus 3. Now, look, guys, the same thing happens for both of these. Minus 3, you get x is negative 3, x is negative 3. And there's kind of my 3 roots. So let's look at the graph real quick. All right, look at the graph real quick. There's my negative 3, there's my 1. Sweet, those are the numbers I found. But look what kind of happens here. I'm going to draw another rough sketch. All right, so I start my graph down here. All right, maybe let's label the x-axis or the x-intercepts first, negative 3 and positive 1. I start my graph down here. It kind of came up and then it shot back down. Okay, it stayed right there. And then, oh, we'll get rid of that line. Okay, it shot back down and then it kind of came down here, shot back up and crossed at 1. So at the negative 3, it actually touched the x-axis and shot back down. But at the 1, it crossed through. Okay, pretty interesting. All right, now, so look, we kind of looked at a linear, a quadratic, and a cubic so far. So on this next page here, all right, you kind of got some bigger polynomials, but kind of similar things are going to happen. Look, so let's simplify this down. X plus 2, there's 2 of them, so I'm going to make it x plus 2 squared. And then be careful, x minus 2 is on its own. There's nothing to simplify that with, and same thing with x minus 3. So think about the multiplicity, guys. Here, look, there's 4 factors here, and then look, even when I combine them, 2 plus 1 plus 1, the degree is 4, the number of solutions is 4. Now, same thing. Could I get x-intercepts just from those factors? Yeah. Okay, I could also get them from the graph. But, like, look, from the factors right here, if you set x plus 2 equal to 0, you'll get negative 2 twice because of that exponent of 2 right there. And then look, plus 2, I'm gonna clean that up, plus 3 for the last one. And look, if you're not sure, if you don't believe me, let's go look at the graph. I'm gonna flip on this 4th one here. And look, negative 2, 2, 3. Sweet. So if I go back to this, all right, we have negative 2, 2, and 3. Same thing. I'm going to draw a rough sketch, guys, because my graph's kind of smaller, okay? I just really want to get the shapes what's happening, all right? Because, yes, I know this graph shoots up a pretty big amount. Like, look, that's almost 25, okay? So, look, it grazes and touches here at negative 2, and then it shoots through both the 2 and the 3. So, I starts up top, kind of comes down, grazes here at the negative 2, shoots back up. It's going to shoot through the 2 and not give myself a bunch of room, shoot back up through the 3. And look, that kind of matches the shape for a degree of 4, right? A quartic. It's got 3 turning points. The end behavior is going in the same direction, even. Sweet. So then look at the negative 2. That's going to be a touch. and then the 2 and the 3 are going to be across. Awesome. So to finish up these last two examples before we kind of look at the summary. All right, this one, only slight weird thing. Look, x, x, and x. Guys, that just kind of combines to an x to the third. There is no like plus or minus with them. And then look, the x plus 3s you can combine into an x plus 3 squared. So look, that's adding the 3 plus 2. This is a degree of 5, meaning I have 5 roots and solutions. Okay, now what are those? Now be careful, guys. X here. All right, let's use the graph maybe this time. Now look at this graph here. Look at my two x-intercepts, -3 and 0. Now, does that match up the algebra that happens here? Yeah. Like x cubed, if I set this equal to 0 and x equal to 0, guys, there's nothing to solve. You just get x is 0. Okay, that was a bad last 0. Let's change that. A little better, I guess. Okay, and my x plus 3 equal to 0, -3 minus 3. There's where I get the 0 and the -3 from my picture, right? Okay, now something kind of interesting happens here. So it starts down low, it shoots up and hits that -3, comes back down, and then look what happens. It kind of like does a little mellow out here at 0. We're going to talk about why this happens in the summary, okay? But as I shoot this up, it kind of comes through, mellows out, and then when it shoots back up here, okay, excuse me, this is the mellow out. It gives me a little bit of a different shape. It didn't just cross through a line like a lot of these other ones, like maybe look at the last one, like these two did. Look, line, line, okay? There's a reason for this, which once again, we're going to kind of look at in the summary a little bit. So that's why, look, the -3 is going to be a touch and a touch, but then my 0 does cross through. It just crosses through a little bit differently, and I want to take a little note of that before we look at the summary. Okay, so to finish up this page, all right, our last one here. Look, you just have just an x minus 2, okay? You have an x plus 3, there's 2 of them. And then an x minus 1, there's a 3 of them. So 3 plus 2 plus 1 is going to be a 6. And so let's take a look at this graph. So let's open up this last one here. And look, you get a 1, a 2, and look, I got to zoom out. A -3, a 1, and a 2. Now, does that match what we have here? Yeah, we had a 2 from this first one. You have 2 -3s, and then we have 3 positive 1s. All right, so let's do this sketch real quick. So it starts up top, it comes down and touches the -3 and shoots back up. All right, so we can start with that. And then look, at 1, it kind of does that same thing from the last one where it kind of mellows out. It's a kind of a cubic shape, if I want to get ahead of myself. And then it goes back up and shoots through 2. So it starts up here at, going to go to -3, 1, and 2. So it starts up here, shoots back down, touches, and comes back up. Through the 1, it kind of does that kind of mellow out again, and then it's going to shoot back up through the 2. So once again, that's pretty messy, guys. I apologize. Not a ton of room to work with here, if I'm being honest. I wanted to kind of really try to show you the mellow out there, but that's what that's going to look like. So then my x equals 2 as I finish up here. At 2, it went through and just crossed, kind of a straight line like that. All right, the -3, it touched the x-axis, kind of came down and touched like that. And then at the 1, it also crossed, but it wasn't a straight line. It kind of came through and mellowed out. There's a reason that it was these 3 shapes. We'll look at that in the next summary, okay? Sweet.